So in source, you see I put this in as an answer. So this is how I would sort of go about some of these things. So there are things like, look, I'm scanning the first 100 ports, which isn't really necessary, but I just wanted to see, what was in there, so you can kind of have a look and see what you do on other ports. So let's just cut that bit out for now. So target is still set. So this is obviously not the full version because you want to be able to do this with input, but that's not a particularly difficult thing to do, or to use sys.argv. The way I've approached this, you can ignore the colouring stuff, but the way I've approached it is that there's a message. And remember, I said this before, that there is a fairly standard pattern to this kind of stuff. You might start off with a number or a string, and you build up the answer as you go through processing stuff. And then at the end, you go, right, now I've got the answer. So here I've said the message is equal to, well, at the moment it just says it's equal to closed, and it's in red, but that's really matter. And then we say found is false and result is equal to test port, right? So we set up some basic things. And actually test port on target P, because P is each of these numbers in this loop, is going to do all of the work for us. The rest of it is just deciding what we want to do about the answers that we get back. So this will return none if there's anything in there. So if there's nothing there. So if we get result is none, means that it is something that we can ignore. It's a closed port. But if it's not none, so if not result is none, now seems like an odd thing to say in English, but there is no Python for isn't. Okay, it's just basically this is what it is. Not result is none is same as saying if result isn't none. Then we say, right, we found something. Okay. Then we check if the result's length is greater than 0. So we're making sure we actually got some data back. Okay, so remember that test port returns either none if the port is closed, or returns a list where each item is a line of output. Okay, so if you've got multiple lines, it's got multiple items in there. And so we check this, and we check to see if the 0th item, that's the first item in the list, is equal to the magic sequence that we expect from wider. Has anyone actually worked out what this magic sequence is?
Nobody's saying anything yet. Somebody did comment though that if X is not none, rather than if not result is none.
No, because not, you don't say not none. So not inverts a boolean. So yeah. I know it seems odd, but you kind of just get used to it. So not takes a true or a false and makes it the opposite way around. Right, that's all it does. But you can't say if something is not something, okay? Because what it will do is it will try to turn the none into the opposite of none, which is either going to be either true or false. I have no idea what it would do with actually, but it certainly wouldn't be what we want. Let's see. So if X is equal to true, not X is equal to false, you see? But if X is equal to none, not X is equal to true, right? So it's a little bit of a weird thing. So works there, but doesn't work for lots of things. So is result is not, yeah, but then also we've got a sequence, haven't we? So what we'd actually be saying is, let's say A is equal to 1, 2, 3, and we want to check to see if it's none. A is none, returns false, okay? But turn it round. God, that's awful. Okay, I'll give you that. It sort of works, but I don't like it. All right. There's too many corner cases where that won't be right.
Yeah, that's true.
Let's pretend we never discovered we could do that and just don't do it. Okay. So let's have a look. Just because I'm drumming to people this amazing tool. So CyberChef, probably already mentioned, it's developed by GCHQ and can be used to convert data into various different formats, do very useful things with sort of crypto stats, on it, various bits of logic. My favorite thing about it though is magic. Okay, and magic has a guess at what it might be, and it guesses that actually it's just hex codes for characters with spaces in between, and that it comes out as welcome to wider. Okay, so that's what that actually says. So that's why, and that's a really useful thing for lots of things. Anyway, if we find that the result is greater than 0 and the first item is this, and a bit of an aside here, but if this wasn't greater than 0, then result 0 would actually cause us problems. So let me just pop up another terminal. Actually, no, let's go and do it over in the one I made nice. So if we've got something that is an empty list, and I say, A0, we get an error. That's bad. Okay. So if I said if A0 is equal to something, print something. Okay, it doesn't really matter what, and we get an error. But if I said if the length, so len A is greater than 0, and this, we don't get an error. And it's an important thing about this and in many languages that when you have an if statement like this, actually it's not really about the if statement, it's more about this operator, the and in the middle, well, this is where it's used. It will check this first thing, and when false, whatever's on the right hand side can never turn it to be true, because false and anything is false. So it doesn't evaluate the right hand side if the left hand side is false. Okay, so if this and this turns out to be false, it never tries to look in position 0. And that's actually a really handy thing. It's the same in lots of languages. So conversely, if we said if something here that was true, then it's always going to evaluate the second half. Okay, all right. So it checks if it finds a special string, it turns the output green and puts wide arm malware detected. If it's otherwise, so it got a result, something came back, but it was either it wasn't that text or there was actually no text, but it did connect. Okay, then it turns it yellow and it says it's open, non-wider. Then it adds onto the end of whatever message we've got at the moment. So notice here, say message equals closed, and then here we say message equals this. So we haven't added to it, we've replaced it. But here we're adding on to the end. So plus equals is the same as message equals message plus. We're adding this reset onto the end. So remember from the colored library, this is what resets all the colors, and off we go. And then here's a nice bit at the bottom, which is useful. If the length of the result is greater than 0, so regardless of whether it's wider or not, it picks up some characters and displays them out of it. So the length of the sample is 10, and then we strip off any white space and we display the data that's there. So actually a bit out here, I've commented out, but here the length of the data is greater than the sample length that we want, then it replaces it with just the first parts. And we'll come on to exactly how these bits of notation work today, because they're the topic of the session. And then at the bottom, we get this if found, then we print the port and the message. So whatever's added together gets added along. Okay, so let's run it. So let's see, Harbourmaster, activate the virtual environment, so that their libraries and things are there. Okay, we can see there it is, and so now we can go into source and run Harbourmaster answer. Now it should be that nothing comes up because I haven't started the target, so let's just wait and see. While it's doing that, I'm going to pop up the terminal. It's very slow. Let's just kill it. It's too slow. Because there's there, it's trying the port and it's waiting for an answer. Okay, here it will actually get a rejection to closed port. So it's not really important for the programming particularly, but from a sort of cybersecurity point of view, it's interesting because what it's telling us is that if we have a non-existent host, then it's different to having a host with a closed port. So a closed port generally gets you a rejection because the host, that IP address would say, no, nothing going on that port, please go away. And so you get a rejection. That's how the port scans work. If you wanted to be really paranoid and make life difficult for people trying to port scan, what you would do is you just drop all packets to ports that you don't have open, and then what happens is that they find it very difficult to tell whether there's a host there or whether there's just nothing on that port. Okay, so until they hit a port that's actually got something open, it can really slow down efforts like that. Okay, now let's run it with something open, and there we go. Wider malware detected. So it found on 3700. Okay, and there's a little snippet of stuff. Okay, so you can see we've got the color and all that kind of stuff in there. Let me just put back. These are the ports because at the moment it's just finding it straight away, or maybe just move this one to the end. No, because we still won't see it. So. Okay, so you can see here we've got other stuff that's open. So you can see the SSH port is open, port 80 is open, but these are non-wider. Okay, and if we wanted to show everything, so not just the stuff that's found as open ports, then do it like this, and there we've got the closed messages as well, so we can see everything's going. So that code is all available for you, and you can have a look through there. It's useful. It's kind of lots of useful bits of coding in there. Like how to stick lists together, how to check the length of things, and a lot of these we're going to go through in more detail today. So if some of these you're not used to yet, if you've read through the documents and stuff that we've given you, don't worry. We're going to go through some tutorial wise. We're going to go through some of these today as well. Okay. Does that make sense?
I think so.
Brilliant. In which case, I'm going to move us on to the scheduled session. Which
some of the questions that we've had are things like why are we doing this? And I said, apart from being able to write your own tools and understanding how these things work by programming them, all of these things will make you a better hacker. They just do. But also, ideally, we want you to learn how to program as well. So that's kind of why we get you to do it.
So yeah, it's the why of it is a few different things. In programming modules generally, you'll have similar kinds of things, except you go through and you'll just do stuff that's arbitrary. Okay, yeah. So we're looking at the answer for.
If you'd like to see arbitrary, look at the docs that I'm writing for you guys, because there's a lot of arbitrary code there.
So just looking at the answer here, it's actually it's not a very big piece of code. The stuff that's in there, adding colors and stuff was all kind of optional stuff. It's not that complicated. This would be the equivalent of going through and doing FizzBuzz or something like that, which is like a common looping thing. And those kinds of examples and challenges you find, we'll go through stuff like that today. You'll see stuff like that in the documentation, the links we put up. The point of the projects is to show you how this stuff works in real life, because one of the things that people tend to struggle with is turning those things into real things. And so the idea of do you need to be experienced to do these things? Is no. This is the way you become experienced, because otherwise you never really get to see anything in use. And one of the things that we wanted to do was to try and do programming in such a way that you don't spend the first year learning to program and then hopefully in the second year learn to use programs in cybersecurity, when actually half of the stuff you would do in cybersecurity can be done with quite a small amount of code. So yeah, you don't necessarily need to be an expert to use Python to do some automation in cybersecurity. Of course, the more you learn, the more you can use it for, the more you can automate, the more you can do. So interesting to see everyone's talking about sort of mindset and how to go through it. My personal view on learning Python, or actually any programming language, is to throw yourself into it. Take on the challenges. The only way you really get to learn about it is to go at it. And for the people that have been, asking questions, coming up with stuff, trying things, to go over and above the basics and try them out, even if they've never tried it before. I can already see people like making those leaps. So the Monday and Friday sessions, where people can just go, look, I don't know how to do this. This is what I've tried to do, are learning faster than if they'd have just said, well, I'll wait until someone tells me. Right? It's just the way it goes. And programming is definitely one of those subjects that you can't learn just by reading about. You have to actually, sit and do. Bogdan, you got your hand up.
Hello. Back into the algorithm. I was just wondering if we can't just ignore the first condition on the if statement, like the length of the result greater than 0. I mean, if the result is that string, it's pretty clear that it's not
yes.
0.
But this is the problem, right? So this isn't the string. So we're not checking the length of the string. We're checking how many strings there are. So we're making sure, is there at least one string? If there is, let's have a look at that first string and see if it matches. Does that make sense?
Oh, all right.
Yeah. Because you're right. Otherwise, if we knew it was a string and it was just a string, then we can check to see if it's that, and we don't care whether it's 0 or not, because it'll either be the one we want or it's not. But in this case, it's slightly different.
Oh, all right. Thank you.
No problem. It's a good question. Right.